Hi, good morning. Today I'm going to go over a couple of examples from yesterday's homework. You'll get some more practice today with today's assignment. Alright, so again we are looking to find the summation for these different sequences described by these expressions. Alright, so again we want to try to be able to rewrite it by either using a property to start. These are the notes from yesterday. And then when we're actually ready to calculate some calculations for sums using a formula. Okay, so I'm going to be referencing these as we go through these two examples today. Alright, so number 4, you're asked to find a summation for this particular sequence. So the first thing we're going to notice is that this expression is made up of a subtraction of two terms. Right, so I'm going to rewrite it, first of all, as... Now I'm going to leave out the rest of the summation notation. Right? We can put it back in here later. So one of the properties we talked about is that when you have a subtraction like this, is that you can rewrite it as a subtraction of two summations. Alright, then we're going to focus on this one right here, and this is a constant times an expression of n squared. So again, when we have that, we can use that one property. It says we can pull out that 5 as a factor and multiply it by the summation of n squared. Okay, so there we've used the properties. So now we can go ahead and use the formulas. So again, let me put back in this notation from the first term to the fifth term, from the first term to the fifth term. Okay, so again, I just put that back into the notation. Alright, so I'm going to look at this summation first. So there we have a formula where we're going to plug 5 in for n. Again, I'm using the formulas from this part of the note sheet. Alright, so we're looking at n squared. So I'm going to be using this formula here right now. Okay, so we're plugging our nth term in for n. I'm going 5, so that's going to be 5 times 5 plus 1 times 2 times 3. Alright, so all of this is coming from this summation. Again, using the formula. Alright, I'm going to bring down this 5, so I'm going to multiply that times that. Then we're going to subtract this next summation. So again, this is about a constant. So again, going back to our sheet, here for our formulas, when we're taking summation of terms, when we just have a constant, it's just n times c. So whatever the nth term is, times that constant. So my nth term is 5, and my constant is 1. So there's that summation. Okay, so this first half is this summation, the second half is this summation, using the formula. Okay, so again, here's something that you just plug right in your calculator to get that answer for number 4. Alright, we move on to number 8. So here we have, again, a summation. So the first thing we're going to notice is that it is a subtraction. So again, like the previous example, I can rewrite this as the difference of two summations. Okay. So I'm going to go ahead and put in what terms we are taking the sum of. So now this one, you notice that we do not start with the first term for the summation. So I'm going to bring you back to the note sheet where we had this property, right, where we're going to break up, right, that initial term into some value plus 1. So we got to figure out what our j value here is so that we can set up that summation in this way. All right, so again, I'm going to be using this predominantly throughout this particular example. Okay, so you might want to have this next to you so you can kind of see where everything's coming from. Okay. All right, so I'm going to rewrite this using finding our j value. So it's going to be the sum of our a. So I'm going to make my j value 4. Again, we want to rewrite this expression down here as some value plus 1. Right? And for it to equal 5, that value has to be 4. Okay. Alright, so a little bit. Alright, so now we want to find this summation. So again, I'm going to be referencing this formula right here, this setup for initial value term j plus 1. Alright, so for this, it's going to be from 1 to 9 minus from 1 to 4. So all of that is coming from this. And do the same thing for the second half, and subtract all of this. Alright, so we've exhausted all that particular property. Now we want to go ahead and use formulas to find these individual sums. Alright, so again, because this is a constant, we're going to use that one sum formula. We're going to take our n value, our term number, multiplied by that constant. Our n value multiplied by that constant. So that's going to help us get that first part of our sum. Here, we've got a variable here for our sequence. So again, we're going to reference this particular formula. This is where that's going to be coming from. And so we've got 9. So the rest of this now is just plugging in your calculator and getting the answer for number 8. Alright? Alright, so again, email me if you guys have any more questions on this. You guys have a great day.